Welcome to Is the Earth Round or Flat? This will be a new series that investigates the claims of the Flat Earth movement and sees if they hold up under scrutiny. Episode 2, Stars. In Episode 1, we investigated how the distance between physical locations reveal a mathematical impossibility. How can the greatest distance be nowhere near as long as a smaller distance? Presented as a simple shape, we saw how a flat Earth creates an impossible triangle, and therefore, the flat Earth could not be an accurate representation of Earth. Today we'll be gazing at the stars and seeing how a flat Earth would make a specific phenomenon with stargazing impossible, and that the Earth must be round in order to achieve such an effect. To begin, let's go to Brighton in East Sussex. There you'll find the famous I-360, a round observation deck on the Brighton coast, located opposite the old pier. Inside is a gorgeous elevating platform that gives you a 360 view of all of Brighton. The platform is built around a central lifting arm. This arm prevents you from seeing directly behind you. Essentially, you are only able to see outwards. In this spherical observation deck, you'll find that depending on where you are located within the platform, you'll only be able to see specific landmarks from different locations. Allow me to demonstrate what I mean using photos that I took from the I-360 this year. Looking towards the north, you can see the city of Brighton. Facing east, you should see the coast and the New Brighton Pier. Turning to the south, you'll see the English Channel and the Old Pier. Finally, facing west, you'll see the remainder of the city and the west coast. The point I'm trying to make is that due to the round nature of the I-360, you can only see certain sites from certain points around the platform. Essentially, you cannot see all of these sites if you remain in the same place. For example, if you're located here on the western hemisphere of the I-360, you should only be able to see this view, not this view on the eastern hemisphere. Simplified, our outward view must be segmented depending on your location: north, east, south, or west. Another example that highlights this crucial concept can be found in a boxing arena. A boxing ring in the center of an arena is surrounded by audiences on all sides. If we placed a multicolored box in the center, we can see that a patron sitting here can only, or at least primarily, see the green side of the box, whereas a patron sat here can mainly see blue. Depending on where they're sitting, you'll find a different view. If the second patron who reports seeing blue suddenly reports seeing primarily green, then the layout of the arena makes no sense at all. How can a patron claim to see a side obscured from his view? Either the second patron is colorblind, lying, or he isn't sitting in this seat at all, but in a seat closer to the first patron. Applying this concept to the stars, a spherical round Earth revolving west to east, with a northern and southern hemisphere divided by the equator, should have a set of stars in the northern hemisphere that can't be seen from the southern hemisphere, and vice versa. Therefore, in order to prove a round spherical Earth, we should be aiming to provide evidence of certain constellation being visible only from one hemisphere and not the other. Now that we have our objective for a round Earth, let's move on to a flat Earth perspective. Instead of a round platform like the I-360 or a boxing arena, we can use the example of a movie theater. In a cinema, all positions are parallel, facing the same direction. In effect, regardless of whether you're sitting in a seat in the back left or a seat in the back right, your view should be the same since the platforms are, quote unquote, flat and do not curve around the screen. Suppose you went to a theater to see Nando, because he's amazing. A viewer sitting in this seat should see the same adorable view of Nando as this viewer, since they're both sitting parallel to one another on a flat, straight seating arena. If one viewer claims to see a totally different side of Nando, despite being in line with the other, then that immediately disqualifies a flat parallel stage, and indicates that the cinema platform must have some significant curvature in order to achieve this effect. Placing Nando in the center, two people describing two different sides of Nando would reveal an accurate layout of one on either side of Baby. In fact, This simple exercise can instantaneously rule out a flat parallel viewing. Thus, applying a flat Earth approach, all perspectives of Nando would need to be the same. And who only wants one view of Nando? Look at him! Applying the cinema analogy to the stars, a flat disc-shaped Earth, regardless of spin, hemisphere, or equator, should have no constellation obscured depending on location on the Earth, since there would be no curvature to create location-based blind spots. In practice, a man in South Africa should be able to see all stars above the flat Earth horizon from his location with no issue whatsoever. Therefore, in order to prove a flat disc-shaped Earth, our objective should be to prove that all constellations are visible from any position on the Earth, since there can only be one view, directly up. Proving this would prove the Earth has no curvature. As you can see, the point of star visibility is significant to practically determining if the Earth is round or flat. But where does the evidence lie? What do we observe in our night sky? To start, the northern and southern hemispheres have their own set of constellations, ones that can only be viewed from their respective hemisphere. Take the southern hemisphere for example. Lots of different constellations here, but let's focus on this one, Crux. Those keen-eyed of you would recognize this constellation from the Australian flag, more commonly known as the Southern Cross. The Southern Cross is featured on the New Zealand flag, the flag of Papua New Guinea, and the flag of Brazil. In fact, it's found on various flags and official labels in many countries, but for some reason, only in the Southern Hemisphere. And the reason for this is going to seem very obvious. You can't see the Southern Cross from the Northern Hemisphere. But why? It can only make sense if the Earth is round, spins, and has a Northern and Southern Hemisphere that is divided by the equator. If you were to make the two halves parallel on the same flat plane, this would make no sense at all. By all accounts, the whole world should see the Nando constellation. But they wouldn't. Only the Northern Hemisphere would. Superimposing this onto the flat Earth model, you can see how the Nando constellation should have no obstructions from the North Pole seeing it, anywhere along the South Pole seeing it, Australia seeing it, America seeing it, the Falkland Islands seeing it, Russia seeing it, and even Madagascar seeing it. But in reality, this is how the Northern Hemisphere visibility would actually be on a flat Earth. There is no reason why this should be the case. Why would visibility be limited to this parameter on the flat Earth model? How is this possible? You could argue that the stars are actually close to the ground and are not high up for areas distant to see. But even then, with our technology, we should be able to see the constellation from all the way here even. But that's beside the point, because in the flat Earth model, it would look more like this, meaning it would become easier to spot any constellation from anywhere on the globe. Therefore, using stars, we can demonstrate practically that the Earth must be round and that simply observing differences in our stars between the Northern and Southern Hemisphere is enough to rule out the flat Earth model and allow us to tally up this episode's scores. Round spherical Earth 2, flat Earth model 0. Thank you for watching. Please subscribe and continue to support the channel.